All right, so we are at the last developmental section. Then it's going to be all college algebra for the rest of the semester. So this is DSMA 12. We're going to multiply and divide rational expressions. We do need to know how to factor to do these problems. So we use rational equations a lot. We don't always think about it, but there's different kinds of formulas. So this one is a dosing for children. And so the child's dose is based on the adult dose and the child's age all over that age plus 12. Okay, so C is the child's dose, A is the child's age, and D is the adult dose for this certain medication. This is called Young's rule. So if we have a 6-year-old child who needs medication, and the normal adult dose is 600 milligrams, it's asking me what size dose should the child receive. Okay, so we're going to put the 600 in for the adult dose. We're going to put the age of 6 in. And then on the bottom, we're going to take, again, the age of the child is 6 plus 12. Pop that in your calculator, and you'll see that you need 200 milligrams for the child who's 6 years old. Okay, now the reason we call this a rational expression or a rational equation is because we have a variable in the denominator and we have a fraction. So rational is just a fancy way of saying a fraction. But what's important is that we have a variable in the denominator, and so we have to take care of these a little differently. We have to watch for what we can't use. Now, not when we're in a word problem like this. That's it. That's our answer. Woohoo! 200, and let's keep going. All right, so again, this is a rational expression. We have a numerator, we have a denominator. We also have variables in the denominator. And so we have to be careful, and we have to check and see where this expression would be undefined. Okay, so what we are going to do is we're going to go ahead and factor anywhere we can. Well, so the top is already factored. We have the numerator is y minus 8. The denominator, though, is a difference of squares. And so we get y plus 8 and y minus 8. Okay, so this is now simplified. Well, not quite simplified. If it was asking me to simplify, then I actually could divide a little further. This problem is not asking for that. This problem is only asking for the values that would cause this expression to be undefined. So remember, we cannot divide by 0, right? If we try, let's come over here. If we try to divide by 0, so let's say we took 5 divided by 0, that's not going to work, right? That is undefined. We cannot divide by 0. So here with this problem, we want to make sure that neither of these binomials in the denominator are equal to 0. So the way to do that is set them equal to 0. So let's take a look. We're going to set y plus 8 equal to 0. That would give us negative 8. So the problem is, if we substitute negative 8 in to this binomial right here, we would get 0. And then 0 times anything is still 0, and we're dividing by 0. That's not going to work. That's going to make this undefined. Same thing over here. If I set this one equal to 0, I get y equal to 8, and 8 would be the same problem, whether I put it in the binomial here or whether I came back up here and put it in the numerator. 8 times 8 is 64. 64 minus 64 gives me 0. So there I am trying to divide by 0 again, which I cannot do, is undefined. And so the two values that would cause this expression to be undefined would be either negative 8 or positive 8. So these are our restrictions. These are two numbers that we cannot use for this problem. And what we're going to find in the next week or two is these are actually going to be what we call vertical asymptotes. But for now, this is the answer. These are the two numbers that would cause this expression to be undefined. All right, so now this is also a rational expression. There's a numerator, a denominator, it looks like a fraction. To add to the fun, I have variables in the denominator in the bottom. And so it's asking me to simplify this expression, but it's also asking me to find all the numbers that must be excluded from the domain. In other words, what numbers would cause that denominator to equal 0? So the first thing we're going to do is factor. We're going to factor everything that we can. So in the numerator, we can pull out a greatest common factor of 4. In the denominator, we can factor. It's a trinomial, so I need factors of positive 1 that sum to negative 2. And so that's going to give me x minus 1 and x minus 1. Okay, now before I simplify, I have to check for exclusions or restrictions, whatever you want to call them. Okay, so we want to do that first. So we're going to go ahead and take, now these binomials are actually the same, so I only have to check one. And that tells me that positive 1 is an exclusion. Positive 1 would cause my denominator to equal 0. Then I would be dividing by 0, and that's not going to work. Okay, so that is when they ask you for the exclusions, we're going to say x equal to 1. We're also going to use these when we get into chapter 3 more. We are going to use these, and they're going to actually be vertical asymptotes because we're going to be graphing these. Okay, so now we're going to simplify. Well, what happens is if the binomials look exactly alike, we can divide them. So remember, if I have 5 over 5, that gives me 1. If I have x over x, that gives me 1. So with these binomials, because I have an x minus 1 and an x minus 1, I can actually divide these to be 1. Now, I can't do it again because I only had the one set. And also they have to look exactly alike or else I can't do this. So now I'm left with 4 over x minus 1. You can leave the parentheses or not. We only need parentheses if there are 2 or more binomials. And so I'm done. So this is the simplified version, right? This is simplified. But I always check for my exclusions before I simplify. Okay, a little more factoring practice. So again, they're asking me to simplify the rational expression, find all numbers that must be excluded. Okay, so we're going to factor. In the numerator, we need factors of negative 72 that sum to 1. And so that's going to give me, what is that going to give me? Y plus 9 times y minus 8. Let's make sure that's right. 9 times negative 8 would give me negative 72. And then 9 plus negative 8 would give me 1 in the middle. All right, so that works. And then on the bottom, I need factors of 9 that would sum to 1. So that's going to be y plus 9 and y plus 1, because 9 times 1 gives me 9. 9 plus 1 gives me the 10 in the middle. So it's the same factoring we've been doing. Okay, now so I factored first. Now I need to go ahead and check for my exclusions. So I'm going to look at y plus 9 and y plus 1. So that means that negative 9 and negative 1 are going to be exclusions for me. Each of those numbers would cause my denominator to equal 0, and then I'd be dividing by 0, which is undefined. So remember, we just set them equal to 0, and that's how we get those answers. All right, now that we have all that, now we can simplify. Well, we only have one thing in common, right? We have this y plus 9, so we can go ahead and divide those and get 1, but that's it. So let's go ahead and grab what's left. Again, you can leave parentheses or not. That's up to you. But that is my simplified answer. And then when they ask me, I'm going to tell them that my two exclusions are -9 and -1. All right, now we're going to try multiplying rational expressions. So we're really going to do the same thing. We are going to factor everything that we see, and then we're going to go ahead and simplify, but after we look for our exclusions. And so this time, instead of calling them exclusions, over here they have x not equal to and a box. So those are the numbers that are going to cause us trouble and cause our denominator to equal 0. Now, before we do this, let's talk about multiplying. So when you multiply fractions, let's say I had, we'll come over here, 1/2 times 1/3. Well, multiplication is the easiest thing that we can do with fractions because we just literally multiply across. So 1 times 1 gives me 1, 2 times 3 gives me 6, and I am done. Now, we can, though, factor. Like if these are bigger, we can factor and start dividing out to make it easier instead of waiting till the very end and then simplifying. So that's what we're going to do with this. So let's start factoring. So on the top there, I have x squared minus 16. So that's a difference of squares. So that's x plus 4 times x minus 1. On the bottom, I have x squared. So I'm going to go ahead and write both of those. Oh, come on, stylus. Well, maybe I am. X times x. And then on the other side, I have x squared minus 4x. So that looks a little crazy, right? It doesn't have a number on the end. And so really the only thing I can do is bring out the greatest common factor. So I'm going to bring out x times x minus 4. Whew. And then I have x squared plus x minus 20. All right, so I need factors of -20 that sum to 1. So that's going to be x plus 5 and x minus 4. All right, let's double check that. So we would have 5 times -4 gives me -20. And then 5 plus -4 gives me the +1 in the middle. Okay, that's good. But now I need to go look at my exclusions. So, because I don't want to start crossing anything out until I look at my denominators. Well, I have an x here and an x here. So if I come down here and set it x equal to 0, that's going to be one of my exclusions, right? If I put 0 into this first term, I'd be dividing by 0, and that is a problem, right? That's undefined. Then I'm going to look at x plus 5. So that's going to give me -5, right? -5 would be another problem child that would cause my denominator to equal 0. And then finally, when I'm looking at x minus 4, that's going to give me a +4. Because remember, we're setting these equal to 0. So if I set x minus 4 equal to 0, if I add 4 to both sides, I get x equals 4, right? If I set x plus 5 equal to 0, move the 5 over, I get -5. So those are my exclusions. We're always going to check for those first. I like to put mine in numerical order, but you don't have to. Okay, now we can start cleaning this up a little bit. I'm going to go ahead and rewrite it down here. X. So this is all multiplication. Right, all the way across, because that's how we deal with fractions. When we multiply fractions, we multiply the numerators, we multiply the denominators. And now we can clean up. So we know we have an x minus 4 on top and bottom here, so we can divide those to get 1. Looks like we have an extra x here. Whew, that's about it. I don't have anything else in common. And so when I go to write my answer, this is my simplified. So this goes in the first box here because that's as simplified as I can get on this one. because I got rid of everything that was in common. And then I also have to answer my exclusions. All right, let's head to part 2.